Source control with branch protections is the foundation for traceable change. A repository records who altered what and when, but protections ensure the record is trustworthy. Branch rules require pull requests, status checks, and conflict resolution before merging, which prevents accidental overwrites and rushed edits. For example, a protected main branch might demand 2 approvals and a passing pipeline before accepting new code. Without protections, a developer could force push a shortcut that breaks production and erases context. E1 looks for objective proof, such as screenshots of branch policies, examples of rejected pushes, and histories showing merge reviews. Use meaningful commit messages and tie them to work items so code and intent travel together. Limit direct write access to a small set of maintainers and use signed commits where feasible. The practical outcome is fewer surprises, faster audits, and an easier time reconstructing decisions when defects surface weeks later. Code review and approval workflow transform individual effort into team assurance. A second set of eyes catches logic errors, unsafe patterns, and missing tests that the author can't see. Reviews should focus on risk and clarity rather than personal style, with checklists that include security considerations like input validation and error handling. A simple scenario is a reviewer spotting a missing authorization check on an administration endpoint before it ships. Require at least 1 approver who did not write the change, and consider raising that to 2 for sensitive modules. Avoid rubber stamping by enforcing that all discussions are resolved or explicitly deferred to a tracked issue. E1 assessors value evidence of real dialogue, comments, requested changes, and final acknowledgement that risks were addressed. Over time, a consistent review culture shortens onboarding, raises code quality, and creates living documentation embedded in the conversation around the code itself. Secrets management outside source repositories prevents the most avoidable exposures. A secret is any value that grants power tokens, passwords, keys, and does not belong in code or configuration files under version control. Instead, store secrets in a managed vault, inject them at runtime, and scope them to the smallest necessary privilege. Picture a developer accidentally pushing a database password in a test script. An attacker who finds it can walk into production if practices are lax. Prevent this by integrating scanners that block commits containing patterns for keys and by rotating any secret that is suspected of exposure. Document how secrets are requested, approved, and revoked, and log who accessed them and when. Treat sample configuration files as templates with placeholders, not real values. In E1, the message is simple and strict. If it grants access, it must be controlled, auditable, and replaceable without touching source history. Static analysis integrated into the pipeline acts like a grammar check for code security and correctness. Static tools inspect source without executing it, flagging dangerous patterns such as unchecked inputs, insecure cryptography, or resource leaks. When the analysis runs on every pull request, issues surface before merging, which is the cheapest time to fix them. For example, a rule might block use of weak hashing and suggest a safer alternative with a clear migration note. Avoid the misconception that static analysis replaces review. It complements human judgment by catching what I skip under time pressure. Tune rules to reduce noise, set severity thresholds, and require remediation or explicit deferral with a tracking item. Keep baselines so new alerts stand out. In E1, integrating static checks proves that the team systematically looks for classes of defects and has an auditable record of what was found and how it was addressed. Dynamic testing for web applications exercises running code to discover issues that only appear at runtime. This includes input fuzzing, authentication flow checks, and basic probes for common weaknesses like injection or broken access control. Run dynamic tests against a staging environment that mirrors production with realistic but non-sensitive data. A simple example is verifying that a low-privilege account cannot view administrative dashboards even by guessing URLs. Avoid believing that a single weekly scan is enough. Instead, trigger tests as part of the release pipeline and after major configuration changes. Capture results automatically and link them to the build that produced them so remediation is targeted. When tests fail, block promotion until fixes are verified. E1 values this evidence because it demonstrates that protections actually work in a live setting, not just on paper, and that failures lead to predictable, documented action. Build integrity and artifact provenance ensure that what you deploy is exactly what you built, from known inputs with traceable steps. Reproducible builds, checksums, and signed artifacts establish a chain of custody from source to binary. Store build outputs in an artifact repository with metadata that references commit hashes, dependency manifests, and pipeline run identifiers. Imagine needing to roll back a release only to discover the binary cannot be matched to a specific commit. Provenance prevents this uncertainty. Lock build agents restrict who can trigger releases and keep secrets out of build logs. Avoid manual steps that allow substitution of unverified components. In one, signed artifacts and documented provenance serve as concrete proof that the deployment process resists tampering and that every byte in production can be traced to a reviewed change and a recorded build with known materials. Deployment gates and change records connect readiness to permission. A gate is a condition that must be met before promoting. Code tests pass, scans are clean, approvals recorded, and a change record explains the who, what, why, and when. Automate gates so they are hard to skip, and teach teams to treat a failed gate as valuable feedback rather than a hurdle. For example, a deployment might proceed only if error budgets are healthy and no high-severity vulnerabilities are outstanding. Record each promotion in a ticketing system with links to commits, build numbers, and approvals. Avoid ad hoc hotfixes that bypass the path. If an urgent change is required, give it a fast but visible lane with the same documentation. E1 aligns with this structure because it proves that production changes are deliberate, reversible, and attributable, which are the ingredients of steady operations. Logging, tracing, and error handling inside applications create the visibility needed after deployment. Good logs describe user actions, system decisions, and failure reasons without exposing secrets. Tracing connects events across services with a shared identifier, so a single request can be followed through multiple components. Error handling should fail safely, return helpful but non-revealing messages, and capture context for diagnosis. Consider a scenario where a checkout fails. Structured logs and a trace identifier allow rapid reconstruction of the path and isolation of a misconfigured dependency. Resist the urge to log raw credentials or full payloads that include sensitive data. Provide log levels that can be raised during incidents and lowered afterward. In E1, application-level observability complements infrastructure monitoring, demonstrating that the team planned for learning and repair, not just for the happy path. Security defects prioritized and tracked keep risk reduction honest and visible. Not every issue is equal, so classify findings by severity and exploitability, assign owners, and set due dates that reflect impact. Use a single backlog for security and functional work so trade-offs are explicit rather than hidden. For example, a high-severity authorization flaw should preempt a cosmetic feature because consequence drives sequence. Avoid the misconception that closing a ticket equals closure in reality. Verify fixes with tests and scans and watch for regressions. Provide leadership with simple metrics such as time to remediate and open issues by severity. In E1, this discipline shows that the team treats security as part of delivery quality, with records that explain what was discovered, how it was addressed, and when confidence was restored. Evidence tickets, pipeline runs, and screenshots turns practices into verifiable proof. Tickets show intent, discussion, and approval. Pipeline runs show automated checks and outcomes. Screenshots anchor configurations and policies at a point in time. Assemble small, representative packets that tell complete stories, such as a dependency alert blocked in the pipeline, the decision to upgrade, the merged fix, and the green build that followed. Capture branch protection settings, secret scanning rules, and artifact repository policies to show that guardrails exist outside individual good intentions. Keep examples current by pulling them as part of regular retrospectives, rather than saving everything for an audit week. E1 reviewers look for consistency across artifacts from different dates, which signals that the process is lived daily and that evidence arises naturally from the way you build and ship. A disciplined and auditable development lifecycle creates software that is easier to trust, easier to maintain, and easier to recover when mistakes slip through. Each practice-clear environments, protected branches, thoughtful reviews, safe secrets, vetted dependencies, layered testing, verified builds, and gated releases adds a small layer that, together, feels like calm rather than friction. When logs are useful, defects are prioritized, and evidence is routine, assurance becomes a property of the system, not a performance for visitors. E1 rewards this posture because it can be shown without staging and because it improves outcomes even when no one is watching. The lasting message is straightforward. Build in visibility, decide with intention, and leave a trail that explains your choices. That is how development strengthens security instead of borrowing against it.